Successful explorers navigate by the stars. They've been doing it for centuries on this planet, and now the Earth is almost entirely mapped. The explorers among us, though, are still quite busy. No longer content to just steer by the stars, they are taking the first tentative steps of navigating to the stars. Mankind's latest scouting mission is the Voyager 2 spacecraft. Last time it made the headlines, Voyager 2 blazed a trail at the distant Saturn and sent back word of places greatly different than our home. I'm Bryce Zabel, and there's little doubt that our continued progress in technology continues to expand the questions we can ask as well as the answers we can receive. But our fascination with this huge, strange planet named Saturn so far away goes further back than computer chips or even radio transmissions. Only our ways of looking at Saturn have changed.
The ancient Greeks were among the earliest of astronomers, but when they looked up at the night sky with the naked eye, the planet Saturn appeared as little more than a pinpoint. Even colorful Greek mythology couldn't anticipate the wonder Galileo must have felt staring at Saturn through his primitive telescope in the year 1610. He saw not just a sphere, but a fuzzy outline around its middle as well. Allowing for the limits of his telescope, Galileo reasoned that Saturn had a pair of guardian satellites, positioned like ears or teacup handles. Dutch astronomer Christopher Huygens cleared up Galileo's mystery half a century later. Huygens' telescope revealed a ringed planet and posed a perennial puzzle for scientists. Jean-Dominique Cassini divined a division in Saturn's ring structure in 1676. We still call it the Cassini division, and we still don't completely understand it. Percival Lowell took a closer look in 1915, 300 years after Galileo, but Saturn's mystery was still very much intact. The mystery continued even through the glass of a modern 120-inch telescope. That was the best we could do until space-age technology sent Pioneer 11 halfway across the solar system in 1979. The view from the top was better, but the image was still blurry. That all changed in 1980 when Voyager 1 found out more for us about Saturn than all of humanity's best efforts previous. The pictures were stunning in their clarity, breathtaking in their beauty. How much more will we learn from Voyager 2? That could take a while to determine. These new photos, though, are food for thought, and they'll have to sustain our appetite for a good long time. We're not going to have a planetary press pass like Voyager 2's cameras gave us anytime soon.
Science became theater in August of 1981. The star was a planet, the stage, the solar system, and the audience was everyone. Voyager 2 brought the house down back then in one wild week. It was a three-act play of science, sightseeing, and suspense.
Voyager 2, now traveling at over 25,000 miles per hour, is closing fast on the ringed planet. The robot spacecraft has strayed over 1 billion miles from home. All the while, Voyager keeps in constant contact with its makers. It takes an hour and a half at the speed of light for Voyager's signals to reach the Earth, but the messages are already stunning. Scientists, used to seeing the fantastic on their monitors, are still surprised. Tethys is one of Saturn's many known satellites, or moons. Even with the best of Earth-based telescopes, it is still just a point of light. When this photo is taken on Monday, Tethys becomes a place. As a member of the Voyager imaging team, Dr. Carl Sagan is one of the first human beings to see these amazing pictures. Yet as Voyager moves toward a close encounter with another mysterious moon named Hyperion, Sagan, too, can only speculate.
Hyperion is one of the outer satellites of Saturn. It's, let's see, it's between Titan, which is the big moon with the atmosphere and the clouds of organic matter, and Iapetus, which is the funny moon, which is dark in one hemisphere and bright in the other. And Hyperion lives between it, and you might figure that it's funny also, considering the neighborhood in which it lives, but we don't know yet.
Soon we learn Hyperion is more mysterious than ever expected. It is irregular shaped, like a hamburger patty, some say, and it may have been recently impacted, knocking it out of its normal orientation. Such pictures of small worlds a billion miles away are made possible because the Voyager 2 spacecraft has learned by experience. It has been extensively reprogrammed in flight based upon the mission of its sister ship, Voyager 1, which encountered Saturn in November of 1980. While Voyager 2 moves silently toward its destination, reporters from all over the Earth converge noisily on theirs, the Jet Propulsion Laboratory in Pasadena, California. Inside JPL's Von Karman Auditorium, the press room is filling up quickly. Print reporters hammering out copy to deadlines. Television crews shooting for the evening news. Radio reporters jockeying for that latest statement.
You have science writers who are highly skilled in the technical, very, very highly technical aspects of this flight. And then you have those of us, say for radio, who are interested in trying to convey a sense of excitement, a sense of perspective, and who are trying to boil the very, very technical elements of this flight down into plain English for the layman to understand, those people out there who are actually paying the taxes to put Voyager up in orbit.
The man truly in charge of making sure the public understands what it's paying for is Frank Bristow. This is the 27th mission newsroom he has organized.
It can get so bad here by tomorrow that people won't be able to get through the crowd. There was a situation last year where a cameraman couldn't get through to his camera. Well, this year we've taken we put up a little bit more traffic control to at least make sure a man can get to where he has to work. But the crowd is enormous and our facility is just so large.
It is August 25th, 1981. Voyager 2 arrives at Saturn. At closest approach, the spacecraft will be a mere 63,000 miles above the cloud tops of the ringed planet. The spacecraft will be working non-stop, surveying the atmosphere of this gaseous giant, looking closely at its moons, studying its rings. The information gathered in this one day will keep scientists busy on Earth for years. It is a fact that does not escape them.
Today is the day of challenge, where we're going to be challenged by our new views of Saturn. I think it's fair to say that everything we're seeing today, basically everything we're seeing today, will be new.
Stone's day of challenge also turns out to be a day of triumph. The pictures were all anyone had hoped for, and more, particularly those of the rings. Although color enhanced to highlight differences in the ring makeup, those pictures clearly were more amazing than those obtained by Voyager 1. Because of Voyager 2's different approach, the rings were better lit, and that showed them in greater detail and greater number than ever. Even the scientists who studied them found reasons to rethink the old theories.
Early in the approach by Voyager 1, we had estimated that there were hundreds of rings, and by the time we got through, that estimate grew up to perhaps something like 1,000. Just preliminary counts now within particular regions of the B ring suggests that we underestimated again, and that the number of features throughout the entire ring system should be stated as thousands.
Scientists studying those rings had to watch a lot of television, and television in turn watched a lot of them. Each day for a week, 4 or 5 scientists would try to tell hundreds of reporters in an hour and a half what's happened a billion miles away in the last 24 hours.
A final set of radio commands has been sent out across a billion miles of space.
Reporters were busy this day telling their audiences the evening's close flyby could be the end of an era of pure space exploration. Some called the Saturn encounter the last picture show. Across town in Pasadena, the pictures were selling like limited editions. Planet Fest 81 was having its own encounter to celebrate what organizers called the initial mapping of the solar system. The 80,000-member Planetary Society was taking its message of exploration to some very receptive audiences.
I think it's really the future of where our society lies today.
I like the stars. We know all about Earth, and we want to know what is it about up there.
Encounter Day was not a day to think of slashed federal budgets. It was a day to dream of what man could do if he wanted to try.
Saturn, I suspect, in 50 years is going to be kind of the advance outpost on the way out of the solar system, because it doesn't have the intense radiation belts of Jupiter, but it has abundant resources, primarily the volatile elements, hydrogen and oxygen, which, of course, make very good rocket propellant, and I think it's...
All that was future. Voyager 2 belonged to the day. At 8:26 that evening, Pacific time, Voyager 2 was at its closest approach. Then it dipped below the ring plane, and this is what it actually sounded like. And then it was silent. Voyager 2 was behind the planet of Saturn. Radio signals were blocked. Technicians, engineers, and scientists whose lives had long been wrapped up in Voyager's fate waited anxiously. Those of us who had watched Voyager only a few days waited too. And when contact was re-established after midnight, we cheered that spacecraft. We cheered each other. In a way, we cheered for everyone on the planet. Wednesday, August 26th. Voyager hurtles beyond Saturn at 34,000 miles per hour. As Americans awake, they hear of the bittersweet day for JPL's scientists. In the afterglow of a flawless encounter and ring plane crossing, a mechanical jam-up on Voyager's instrument platform steals the spotlight.
It moves in two directions. This is the azimuth direction, and that's the direction of rotation where we're having a problem, where it appeared to get stuck during the occultation time period.
For JPL, it's a major headache. For the media, a dramatic twist to Voyager's meticulously written plot. For all of us, a reminder that we're not perfect, nor are the machines we build.
Here we had an absolutely flawless, perfect mission. I think people are a little sad that a small flaw has crept in. We wanted it to be absolutely perfect, and we've gotten spoiled on that. I mean, if we go from 100% to 99%, people say, oh my gosh, we've lost a percent.
Voyager 2 loses a percent and a few pictures of Saturn's dark side, but Voyager 1 snapped those pictures the year before, so the loss is minimal. Besides, this time around, it's not just a picture show, it's also a symphony. The score was composed by Voyager itself when the spacecraft's hull hit the magnetosphere of Saturn. With the close encounter over and the Saturn mission largely accomplished, Voyager receives a diagnostic exam from 1 billion miles away. Soon the platform is unstuck, and the spacecraft is able to look over its shoulder once more, sending back this final haunting picture of the ringed planet. In a burst of enthusiasm, one scientist will call the mission a 200% success. That stretches the limits of the possible, but in a way, so too has Voyager.
Certainly a compelling story to report. During the encounter, reporters demanded a kind of instant science from the men and women on the job at JPL. That probably makes for better drama on the evening news than scientific analysis. Joining me now to try and correct that imbalance, a Voyager scientist who has had a chance to catch his breath and reflect on all of this, Dr. Edward Stone, the Chief Project Scientist for the Voyager mission. Dr. Stone, welcome to our program. I'd like to ask you, first of all, you're the man who called the mission a 200% success in the first place. I'm kind of wondering, with the continued problems on the platform and it sticking and all, whether you're still sticking with your optimism.
Well, I, of course, was really judging the success of the Saturn encounter itself, and that we really have completed. And as we look at the data in more detail, I think it is clear that we really accomplished a great deal more than we really would have had we carried out the plan that we had put into the spacecraft, we're going to put into the spacecraft last November. By reprogramming it after Voyager 1, we really have accomplished a great deal more.
And in fact, that brings us to the next question. Voyager 1 certainly did a pretty impressive job of mapping Saturn and its system, and then you sent Voyager 2 to do the same. I'm wondering, now that you've got the information coalesced from the two itself together, taken as a whole, what do we know about Saturn as a planet?
Well, first of all, I think it's important to realize that these are giant planets. It's very cold. It's almost 300 degrees below 0 Fahrenheit where Saturn is, and it's a huge rotating sphere, 75,000 miles in diameter, of gas, basically hydrogen gas. And when we look at Saturn, what we're looking at are clouds of ammonia ice crystals at the very top of the atmosphere. We were very puzzled by some of the winds which we discovered on Voyager 1. For instance, the fact that the winds at the equator were 1,100 miles per hour, and that we didn't see the evidence, though, of the circulatory storm systems which we had seen with Voyager 1 and 2 at Jupiter. So we reprogrammed Voyager 2, and as we got closer, we in fact found the evidence we were looking for in terms of the nature of Saturn's weather. I think we have on our screen here, if we can just take a quick look, that's what Saturn looked at like as we were approaching. As we got closer and took a better look, we began to see, as one can see up in the northern hemisphere now, evidence of clouds which are forming. This is a high-speed jet stream here blowing about 300 miles to the east. As we got closer still, we found something which looks a great deal like the Great Red Spot on Jupiter, except it's smaller. This is a brown spot, and right behind it we find storm systems developing. We think those are very closely related to the formation of the jet streams on Saturn.
Fascinating place it certainly has turned out to be. Dr. Stone, I think one of the interesting things about Saturn that made all of us interested in going there and exploring it in the first place certainly had to be the fact that it had the rings. And I know we found out subsequently a number of other planets have rings too. Saturn seems to have one of the most fascinating ring structures around. They were a mystery when we went there the first time. I understand they're still kind of a mystery to you folks now.
Well, that's right. We did get a much better look, though, and I think we're beginning to see the patterns in the rings which will tell us really what's going on, and now that we've gotten a better look. There were several puzzles. One had to do with the so-called spokes. These are clouds of very tiny dust particles, a few 10,000th of an inch in diameter, which appear to form above the brighter regions of the rings. Well, with Voyager 2, we programmed a time-lapse sequence so that we could look at the formation of these spokes. And we can, in fact, take a look at that time-lapse sequence. Here we see in this image the B ring, the bright B ring, and the dark radial looking features are those clouds I mentioned. And we can actually see now with the time-lapse movie how the clouds form and how they're distorted as they orbit around the planet, because they're, of course, small particles in orbit around Saturn, just like the rings themselves are made up of much larger icy objects in orbit around Saturn. Another thing which we were puzzled about for Saturn was, of course, all of the individual streaks or ringlets which we found in the B ring. We had a better look at that in this image. This is still somewhat like what we saw with Voyager 1. That is, the B ring has in it many ringlets. But as we zoomed in on the B ring, we found that it was even more detailed. We found that, in a sense, the surface of the rings of Saturn have waves on them, and those waves are of a different character than we had interpreted from the Voyager 1 images, mainly because we have such much better images and much better data from the photopolarimeter from Voyager 2.
Dr. Stone, just a couple of minutes left. I think one thing that I think a lot of people are interested in, we knew that there were rings out there at Saturn. We also knew there were moons, but we never had even seen some of these moons up close like we did on Voyager 2. Can you give us kind of a best hits of some of the most interesting moons out near Saturn?
That's right. There were several which we had reprogrammed Voyager 2 to take a very close look at. One of the most interesting was Enceladus. And the reason we thought it would be interesting was because from Voyager 1, there was a suspicion that it might be very smooth. And in fact, as this image shows, the surface of Enceladus does have very young regions on it, regions perhaps as young as 100 million years. So we found on the surface of this icy object, and this is an object which is more than half water ice, we found there were regions which were quite ancient as well as regions which were quite young. We also took a look at the satellite Hyperion, and there was probably one of our bigger surprises because we didn't expect to find anything unusual about Hyperion, yet when we did image it, we found it was a very irregularly shaped object, and that means that in fact it had suffered probably some collisions since its formation. And even more recently, we managed to take a rather remote look at Phoebe. The outermost satellite of Saturn is an object which is in fact in retrograde orbit around Saturn. That means it moves in the opposite direction to the main satellites around Saturn.
Dr. Stone, thank you very much. I'm afraid we've run somewhat out of time, but certainly Phoebe will be getting even better pictures of in the future, I'm sure, as you go to work on that. Thanks again, Dr. Edward Stone, who is with the Jet Propulsion Laboratory, the top scientist on the Voyager mission. You know, the fact that there's a lot of information left to go through is certainly good fortune for scientists out at the Jet Propulsion Laboratory. Not until January 24th, 1986 will another U.S. spacecraft once again encounter one of our planetary neighbors. That drought of scientific information isn't being caused by a lack of interest or even skill, but by a lack of money.
As the new year of 1986 begins, Voyager 2 will give us a closer look at Uranus. That planet is almost 2 billion miles from the Sun, has at least 5 satellites, and perhaps even a ring system similar to Saturn's. We know very little else about Uranus. We know even less about distant Neptune. If the spacecraft survives the added 3.5-year journey from Uranus, Voyager 2 could make a close pass of mysterious Neptune, including a flyby of Triton, the largest of Neptune's 2 known moons. Astronomer Carl Sagan says those 2 planets will be a lucky break because the Voyager 2 mission is a pared-down version of the original plan.
These systems were not designed to go beyond Saturn. There was a proposal to do something called Grand Tour, in which there would have been much more redundancy built in and a computer that was its own medical doctor and could examine it, itself. How am I today? Oh, not too bad. Whoops, there's something wrong. I'll fix that. Well, that doesn't exist on the Voyager spacecraft. And if we get to Uranus and it works, that's just another amazement provided by the brilliant engineers at JPL, but no one can promise it.
Grand Tour or not, by 1990 both Voyagers will be on their way out of our solar system on a never-ending journey through space.
T-minus 10, 9, 8, 7, 6, 5, 4. We've gone for main engine start. We have main engine start.
Magnificent as the reusable space transportation system may be, there are some who worry the U.S. unmanned exploration program is being scuttled by the shuttle. The shuttle has been given priority status by the government and NASA. The result is a drought of funding for scientific exploratory missions. The only one with sure funding is the Galileo Jupiter mission, scheduled now for a 1985 launch. Chief JPL scientist Arden Albee.
The Galileo mission is a mission which we have been working on for a number of years. It's a mission which will go to Jupiter, and it will send a probe into the atmosphere of Jupiter to understand its composition, and it will then go into orbit, and it will do a whole series of orbits, sort of like flower petals, looping around Jupiter and then looping around the satellites, and using gravity assists so that it can continue to loop around the satellites. So it's a very detailed mission.
Albee may be relieved about Galileo finally flying, but no one at JPL is very pleased about the Halley's Intercept mission scheduled for January of 1986. It's the one chance we get every 76 years to study the famous comet, but as of now, there are no approved plans to take advantage of the opportunity. The Japanese, the Soviets, and the Europeans plan to do the mission with their less sophisticated spacecraft. That leaves Project Director Ray Heacock a man in limbo. The Halley's mission has just enough study money allocated to keep the option open.
The data we get this time around, whether it be Russian, European, Japanese, or the United States, is what's going to be in the textbooks for the next 76 years. And I think it's important to have us in there doing the best we can to provide the best data that can go in and have that little label under all those pictures and the rest of the data, discovered by the United States spacecraft.
Something else that won't be discovered by U.S. spacecraft are some of the secrets surrounding our sun. The European Space Agency and NASA were scheduled to cooperate in the International Solar Polar Mission to help understand the complex physics of our star. But the U.S. won't be building its spacecraft. Although the Solar Polar and Halley's Comet missions each would cost less than the price of a six-pack of beer per American, they have company and other projects being held back. The Venus Orbiting Imaging Radar mission has been postponed 2 years, from 1986 to 1988. Then it will probe the thick cloud cover of Venus and provide a clear, high-resolution view of our nearest planetary neighbor. And put on the indefinite back burner is the search for extraterrestrial intelligence. If NASA had its wish list fulfilled, a network of stations would be established to listen for contacts from deep space. As it stands now, such a message could be beamed and we would likely not hear it.
The burst of energy that the United States had in the early 60s and through the 60s that carried us through to now has kind of run down. And the real issue is whether it's going to run down altogether or not.
And that's a question that only politicians can answer as they eye the bottom line of our nation's budget. With so much uncertainty about the future, now seems a good time to reflect on what we had during Encounter Week, that time when the world's glance was pointed upward. The object of all the attention didn't turn toward the camera or even acknowledge its presence. It simply continued doing what's natural and right for an icy world of rocks and gases and rings all over 1 billion miles away. We saw views of Saturn and its moons that we had never seen. We measured for things we weren't even sure existed. But in the end, it's these amazing pictures that bring the science and speculation back down here to Earth where we can all share in the discovery. So take a good look. We won't be reporting this kind of story again anytime soon. Bryce Zabel here. See you in 86.
This program was made possible by a grant from Atlantic Richfield, makers of Arco Petroleum Products.